Hello again. In this video, we are going to learn some different derivative rules called the sum, difference, and constant multiple rules. And then at the end, we'll do an example that uses all three of these rules as well as the power rule, which you just learned. So in the textbook, this theorem 3.4 gives us the sum, difference, and constant multiple rules. And basically what these equations are telling us is this right here is called the sum rule, and it says that the derivative of f of x plus g of x is equal to the derivative of f of x plus the derivative of g of x. We can summarize this by saying that the derivative of the sum is equal to the sum of the derivatives. Basically, we can break up this sum into two or as many pieces as we want, in fact, and take the derivatives of the individual parts. This is also true if we have a subtraction sign in there instead of an addition sign. We can subtract the derivatives, and this is the same thing as taking the derivative of the two functions that are subtracted from each other. And then we also have something called the constant multiple rule, which means that if we have this constant k that is being multiplied by our function f of x, we can bring that k outside to the front and then just take the derivative of f of x as normal. So let's use these in an example with the power rule in mind as well. So we want to find the derivative of f of x equals 3x to the power of 4 minus 2x cubed plus 7x. So according to the sum rule, we can split this up, actually the sum rule and the difference rule, right, since we have that subtraction sign in there. We can split this up into several different derivatives. So the derivative of f of x, since this is three separate monomials, we can take the derivative of 3x to the power of 4 and then subtract the derivative of 2x cubed and then add the derivative of 7x. So in this step, we used the difference rule right here, and right here we used the sum rule. We split this function f into three parts, and now we are adding their derivatives and subtracting the derivatives to get our total derivative. The next thing I'm going to do is bring all of our constants out. So we have a lot of constants to bring out. So I'm going to move this 3 out to the front, and I'm going to move this 2 out to the front, and I'm going to move this 7 out to the front. So we can rewrite this as 3 times the derivative of x to the power of 4 minus 2 times the derivative of x to the power of 3 plus 7 times the derivative of x. So this step was the constant multiple rule. Constant multiple rule. We can just bring all of those constants out in front. And now we can use the power rule as we can do. So this is 3 times the derivative of x to the power of 4 is 4x to the power of 3 minus 2 times the derivative of x cubed, which is 3x squared, plus 7 times the derivative of x, which we know to be 1. And now I can just multiply through. So this is 12x cubed minus 6x squared plus 7. So this is our final answer. This may have seemed like a lot of steps, and it was. Once you get more practice with this, you definitely won't have to go through all of these steps, but I did want to show you what we were doing using the sum, difference, and constant multiple rules in conjunction with the power rule. But just keep practicing these kinds of derivatives, because the more you practice, the easier it will get, and then before you know it, you won't even have to think about it. So that's the goal, to be able to compute these kinds of derivatives without even thinking about it, basically. All right, that is it for this video. I will see you next time.